Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We've also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from my college, I get to know about XLR and I enroll in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, Excella.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped. So I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching.
Hi guys. Am I audible?
Yes, sir, you're audible.
Audible, right?
Yeah, yes. You can start.
Okay, we can start. Okay, thank you. So, just 34, the people are joining, let them join first. Hi, Dene. Good evening. What is this? The festive season taking an effect on the batch strength? Just 10% of the batch strength today. Today there was a session, right? I hope people are not into some misunderstanding that due to the
Please
bank
give me a
holiday.
moment, sir. I'm just checking. Please wait for 2 minutes. We'll start then.
Yeah, because I guess being a bank holiday today, I guess people were not informed like that.
No, we have the informed. I'll just check with the backend. Just wait for 2 minutes.
Yeah, sure. Yeah, people are turning in. Okay, let's start, guys. So, just give me a minute, guys. So, yes, guys, let's start. So we had stopped on array, right? So let's take it further from array and discuss the other. Okay, so today okay, so whenever we are playing around with loops, guys, there's one more thing which we need to understand very clearly when we are playing around with loops is the time complexity of the algorithms. Am I audible to everyone? Yes, guys. You can just text me on the chat if I'm audible to you all. Okay, very good. So always remember whenever we are okay. So time complexity means the count of primitive operations. Okay, so primitive operation means the basic operations. Okay, So if we say multiplication is basically addition. So if I say 3 multiplied by 8. So multiplication, the calculator basically what it does, it adds 3 8 times. It adds 3 8 times, and whatever answer you get by adding this number this many times is the answer. So for multiplication, the primitive operation internally is addition. What is it? The primitive operation internally is addition. Okay. So let's say if I have an array, and if I need to search for a number in this array. 50, 20, 60, 10, okay, 90. So if I want to search for a number, let's say I want to search for number 10. So the primitive operation which I do, if I'm doing linear search, okay, if I'm doing which search, if I'm doing linear search, the primitive operation is comparison. What is it? Comparison. So how many times I will do the comparison? So to search for 10, I will do the comparison with 50. Then I'll compare it with 20. Then I'll compare it with 60. And then I'll compare it with 10. So internally, what is the primitive operation happening over here? The primitive operation happening over here is comparison. How many times I am doing comparison? Okay. So the time complexity is the count of time the primitive operation is carried out in an algorithm. Okay. So if I give you all a question that accept a number and check whether it is prime or not. Okay. So if I give you all this task that you accept a number from user and check whether that number is prime or not. If it is prime, display number is prime. If it is not prime, display number is not prime. So how do we get that now? Now the same question can be done by 4 different people. They'll get the same output, but each one will have a different time complexity. Means the number of comparisons they have done is different. Okay, so I'll try to explain your time complexity, and then we will check what is big O of n. So very important for your interview that whenever you explain any algorithm, try to explain it with regards to the time complexity of that algorithm, and try to explain it with the time complexity of O of n. Okay, O of n gives you the worst case. Okay, so worst case, how much comparison I will need will be expressed by O of n. So let's take this example. Okay, this should be interesting. And always when you are explaining your question, always keep an eye on the time complexity, guys. So this is our Intel preparation batch. Today is day 6. New. And I make a new package. Day 6. Okay. And I make a new class. Okay, prime number. And the first scenario of prime number, I do a finish. Okay, now let's try to. So we know that a number is said to be prime if it is divisible by 1 and by itself only. If it is divisible by 1 and by itself only. For example, 7 is prime because 7 in its entire life cycle divides by 1 and directly by 7. So this number is said to be a prime number. So let's take the smallest. Let's take the first simple example. I'm not able to see my Eclipse screen, guys. Now I am able to see my Eclipse screen. Correct? Okay. So let's take a scanner over here. Okay, so I take a number now. I want to reduce the font size. So window. Control minus हाँ ये ठीक है. Okay, ये ठीक है. So ये रहा मेरा program. Okay, makes sense. Is it too tiny, guys? Looks legible, right? You all are able to read. So I do a Control Shift O. Okay, and so now see. Okay, first let me show you what is time complexity. Okay, so the notation which we use to measure time complexity of an algorithm is big O. Okay, called big O, written as big O like this. And now we have various time complexity classes. We have various time complexity classes. Okay, so if I have an array and I am told to display the first number of the array, if I am told to display the first number from the array, I will require only one step. I'll require only one step. So if the array is ARR, I'll require only one step, ARR of 0. I'll require only one step. So this problem can be done in one step only. Okay, so if I have the problem, I can display the time complexity class for that problem. How much I can measure the algorithm. So I can say if display first number from an array is my question. Display first number from an array. So this will take O of big O of 1. This will take only big O of 1. So to display first number from an array, you require only one step. You require only amount of memory required will be space complexity, Gulshan. So we have two trade-off, time complexity and space complexity. Time complexity means how much time that algorithm executes in. So time does not mean CPU time. Time means how many times our iterations are running. Okay. So if someone can achieve the same task by running less number of iterations, his algorithm is faster comparatively. Okay. So display first number from an array, I'll say O of 1 because this will require only one single step. So this is called as constant time complexity. This is called as constant time complexity. So irrespective the array is of size 5 or the array is of size 500, the length of the data doesn't matter over here. So irrespective the array is of size 5 or 500, to display the first number from an array will always take this much time. We always take fixed time. Irrespective the array is of size 5, 500, 5000, array size does not matter. I will just write it one single step. I will say array name dot 0 index. Okay, making sense? Then we have, so if I say find sum of array, find the sum of array. So here, if the array is of size 5, my for loop will run 5 times. And if the array size is 500, my for loop will run 500 times. So this is called as O of n. And O over here means size of the array or size of the collection. N over here means size of the collection or array. So if I want to find the sum of an array and that array length is 5, how many times will I do the primitive operation? The primitive operation is addition. So what will be the code? The code will be for I equals to 0, I less than 5, and I plus plus. Right? This will be the code. And what will I do? Sum equals to sum plus whatever the array name ARR of I. So how many times is the primitive operation being carried out, guys? The primitive operation is being carried out the number of size of the array. So if the array size is 5 times. If the array size is 500, then 500 times, right? Okay, so here if you see, this depends on now my size of the array. So if this addition, initially my sum will be 0. So how many times will this primitive operation happen? This primitive operation will happen n times, n being the size of the array. So if my array is of size 5, it will happen 5 times. And if my array is of size 500, this primitive operation will be carried out 500 times. So if such is your algorithm, that the length of the collection will determine the number of primitive operation, then you are in time complexity O of n. That is called as linear time complexity. So your algorithm is in which time complexity? Linear time complexity if the number of primitive operation is equal to the size of the collection. Okay. Are you getting it, guys? What I'm trying to show you all. Okay, so which is faster now? O of 1 is faster or O of n is faster? So if I have two candidates who come for the interview, Alice and Ben, and Alice does the same task in O of 1 times, and Ben does the same task in O of n times. So who is faster? O of 1 time is faster than O of n, correct? Very good. Then we have the next time complexity called as your quadratic time complexity. So that is sorting algorithm. So I'm told y'all last time y'all had done sessions on DSA, right? So in DSA we had the sorting algorithms. Let's take the simplest of sorting algorithms, selection sort. So in selection sort, what do we do? So if these are my numbers, 7, 4, okay, these are my numbers 7, 4, and 9, 3, 6, and I want to sort them. So what do? I compare them first, and if the number which is ahead is greater, then I swap them. So 7, 4 becomes 4, 7, right? I guess y'all might have had sessions on DSA, detailed session last time around. I was told by the coordinator that they have been. Okay, then what do I compare? Next, in selection sort, 4 with 9. So if it is greater, I swap. If it is not greater, I will not swap. So is 4 greater than 9? No, then I will not swap. So how many comparisons will I make in selection sort? So if you are familiar with selection sort, then what will I compare? 4 with 3. Is 4 greater than 3? Yes. So you swap. So 3 comes over here and 4 comes over here. And rest numbers at their own place, 7 and 9. Okay. And then 6. And then next, what do we compare? 3 with 6. Is 3 greater than 6? Is 3 greater than 6? No, right? So as it is. So as it is. So write it as it is. So now how many? So now this will sort only the first number for me. So if you observe, the first number, that is 3, has been sorted. And now what do we need to sort in the further iterations? So if you do the further iterations, now you need to sort 7964. 7964 needs to be sorted because the first iteration now is complete. Thank you, Kaka. The first iteration is done. Now what will we compare? 7 with 9. If it is greater, I'll swap. If not, I'll not swap. So 7 compared with now 9. Is it greater? No. No need to swap. Write as it is. So I write as it is. Then what do I compare? 7 compared with 4. Greater? Yes. So you swap. 4 comes over here and 7 goes over there. And rest numbers remain on their place. 9 remains on its place. And 6 remains in its place. Okay. Then next, what do we compare? 4 with 6. Is it greater? No. So as it is. So here my second number, if you see, has also got its place. Now my second number also is sorted and my second iteration is done. Now next, what do I need to sort now? The remaining numbers are, which I need to sort, 7, 9 and 6. So iteration 2 also is complete. And now I'm left with sorting 7, 9 and 6. So now 9 with 7, is it greater? Compare. Yes, so you'll swap 7 and 9. And 6 will be on its original place. And then 7 and 6. Greater, yes. So 6 and 7 and 9 at its original place. So now my third number also has got its place. That is 6. And this was my iteration number 3. Now I'm left with which numbers? I'm left with 9, 7. So this is iteration number 3. 9 and 7. Compare here, 9 is greater than 7. You swap 7 over here and 9 over here. And 7 gets sorted. Now iteration 4 also has completed. And now I'm left with only one single number, 9. And now that also is sorted. So what will be the output of this? The output will be 3, 4, 6, 7, 9. So this is your selection sort. So how do I write the loops for selection sort? So the outer loop will keep count of the iterations. Iteration 1, iteration 2, iteration 3, iteration 4 and iteration 5. So outer loop will keep count of iterations. So you start from, for I equals to 1, I less than equal to 5, I plus plus. So outer loop will keep count of iterations and inner loop will keep count of comparison. Okay. So for j equal to, so let's say I equals to 0 and less than 5 and j equals to I plus 1 and j less than 5 minus I. For each time the iteration will reduce. Okay, j plus. So when we have one for loop inside the other for loop, when we have one for loop inside the other for loop, it is multiplication. It is what? So how many times will this display me high, guys? For I equals to 1, I less than equal to 5, I plus plus, and for j equals to 1, j less than equal to 5 and j plus plus. So if I display over here SOP and high, how many times do you think this will display high? This will display high 25 times. So whenever there is a loop inside a loop, it is multiplication. Whenever there is a loop inside a loop, it is multiplication. So this loop runs 5 times. This loop also runs 5 times. So nested loop, one inside the other, will always form a multiplication. So this will display me high 25 times. Let's copy this. Let's copy this and let's try to show over here. Let's try to do a class and nested loop demo. Okay. And let's try to display the outcome. So let's declare I and j. And let's sys out. Okay. So if let's save this, and if I run this code, it will display me high 25 times. If you can see the output, if you can maximize this is 25 times high. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 25 times when you. So if the numbers are 5, if the numbers are 5, this nested for loop will go how many times? 5 multiplied by 5. So that is 5 square. That is what? 5 square. So if there are 5 numbers, I will have 25 iterations. If I have 6 numbers to sort, I'll have 36 iterations. So this is called as n square time complexity. What is that called as? N square time complexity. So this time complexity, third is O of n square. So if I have 5 numbers, my primitive operation, that is comparison, will be happening O of n square times. So if I have 5 numbers, I'll have it 25 times. So if I give a problem, and if A solves it in time complexity of O of n, and B solves the same problem in time complexity of O of n square, whose is faster and who should I then hire? Because they are reducing my time of the iteration, right? So who's faster over here? So if you can save on one single iteration also, you are, yes, 636. So if you can improve on one single and you can save once comparison also, you can still improve on the performance. Then you have O of n cube also. So if you have 5 numbers, it will take n cube number of primitive operation, that is matrix multiplication. So if you try to multiply two matrix multiplication takes care in O of n cube. So if a 2 by 2 matrix, if you multiply them, okay, 1, 2, 3, 4, and 4, 5, 6, 7, okay, to multiply these two matrix, I will require 2 raised to 3, and 8 additions I will require 8 additions. So first row with first column. So 1 into 4 plus 2 into 6, okay. So 1 into 4, 1 plus 2 into 6. Okay, now just give a count of the multiplications. So 1 into 4, 2 into 6. First row, first column. First row, second column. 1 into first row, second column. 1 into 5 plus 2 into 7. Now just give the count of the multiplication now. Then second row, first column. 3 into 4 and plus 4 into 6. And then 3 into 5 plus 4 into 7. So how many multiplications? 1, 2, 3, 4, 5, 6, 7, 8. So a matrix of size 2 will require 2 raised to 3. So this is called as cubic. Okay, so this is quadratic time complexity. Okay, time complexity. And then you have cubic, okay. And then you have cubic time complexity also. So like this, and as the power keeps on increasing, the performance will keep on reducing. So okay, sorry, am I not sharing the screen? Here, this one. So if a matrix of size 1, 2, 3, 4, a 2 by 2 matrix, okay, so if it is same size and same, it is called n into n. So what is the value of n over here? Value of n over here is 2. Value of n over here is 2. So to multiply 2 matrix of size 2, I will require 8 addition, 8 multiplications over here. That is 2 raised to 3. So matrix multiplication goes into cubic time complexity. So if you are given a task and you solve that task in linear complexity, and someone solves it in, or you solve it in constant, someone solves it in linear, then someone solves it in quadratic, and then someone solves this in cubic. So O of 1 is the fastest. So time O of 1 is less than O of n. O of n square is O of n is less than O of n square, and O of n square is less than O of n. In between, we also have log n. So between 1 and n, we have log n. That is your binary search. If you have seen binary search, it works in log n time complexity. Now, what is log n time complexity is? Okay, so this is the speed. So see, I'll explore log n time complexity also. These are very important things for the interview. As freshers, you should be well versed with the time complexities. They're very frequently asked. Okay, my question is, what is log 100 to the base 2? Who will tell me? And what is log 100 to the base 10? What is log 100 to the base 10? So how do we calculate the logs in simple layman language? It's very simple. Yes, so the base 10 is 2. That is correct. So what happens is you take this number and you repeatedly divide it by 10 till you get 1. So in how many steps will you get 1? So if I repeatedly divide 100 by its base, what is the base I have kept? Base I have kept is 10. So 100 divided by 10, what will you get? 10. Now take this 10 and again divide by the base. So how many divisions have I done to reach the number 1? To reach the output as 1. So I have done 2 divisions. These are my 2 divisions. So that's why log 100 to the base 10 is equal to 2. Now, who can tell me what is log 100 to the base 2, guys? Do the calculation. So pretty straightforward, as I've given you all. Take 100, divide by the base 2. So this will give me 50, right? This will give me 50. Again, divided by 2 now, continuously. So this will give me 25. Array, sir. 25. Oh, thank you. 25, right? Now divide 25 by 2. What will we get? 12. So 12 by 2 will give me what? 12.5, right? So this was 12.5. So just add the, we keep carry forward the 0.5. 12 by 2 will give me 6. Divide the 6 again by 2 now. So will give me 3. Right? And 3 you divide again by 1, 2 to the base will give you 1.5, right? So this one and again the 0.5. Okay, if I add them together, so 1, 2, 3, 4, 5, 6. So max it will be somewhere 0.6 and 7. Somewhere approx between 6 and 7. I am getting what I'm trying to show, guys. I am getting what I'm trying to show. So if I have a array of size 100 and I try to do a linear search on this array, if I have an array of size 100 and I try to search for an element by using linear search, how many comparisons will I make? I will make 100 comparisons because linear search is in linear time complexity. It's in linear time complexity. So if I have my 100 numbers, random numbers, I have 10, 8, okay, 12, 35, 19, 8, 6, 15, and I want to search for the number 6. What will I do? I will compare with every number because I don't know at which index it is. So I'll compare with 10, I'll compare with 8, 12, blah, blah, blah. So if there are 100 numbers, I'll compare 100 times. So linear search works in linear time complexity, which is O of n. The number of elements, those many comparisons. But binary search works in which time complexity, guys? Any idea? Binary search works in which complexity does binary search work? Binary search works in log of n complexity. So how binary search works is, but the prerequisite is in binary search, the numbers must be sorted. Numbers must be sorted. So if I have 100 numbers and I want to search for the number 67. So first it will search at the mid always. So what is the mid of 100 and 100? 50. So it will first search for 50. Is the number 50 what you are searching for? No. Is it greater than 50? Yes. So in one iteration, half of my data is eliminated. Divide by 2. Now what is my new range of search? Now my new range of search will be 51 to 100. What is the midpoint? Midpoint is 75. Is the number 75 I'm searching for? No. Is it more than 75? No. So in one shot, this half will be eliminated. Again, divide by 2. Now what is my new range now? My new range is 51 to 74. My new range will be now 51 to 74. Now what is the midpoint? Let's say the midpoint is 125 divided by 2. What is it? Let's say it is 67, as you know. So number found. So I just took 3 comparison and I found the number. Worst to worst case, I will take 7 comparison, not more than that. Because binary search will work in which complexity, guys? Binary search works in which complexity? O of log n. O of log n. So in each iteration, it will filter out the unwanted half of the data. It's like very simple. If I give you an example, if you have a telephone directory of 1000 pages, 1000 pages, you have the telephone directory. And telephone directory, the numbers are sorted alphabetically, right? A, B, C, D, E, F, blah, 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 Z. So if you are looking for a number called, let's say, Smith, you're looking for the surname Smith. As you open the telephone directory from the center, as you open the telephone directory in the center, on the 500 page, on the 500 page, you see the name some Jack, okay? Let's say some surname Jack was there. Now, as we are in alphabetical order, where will Smith be? In page 1 to 500 or on page 500 to 1000? Yes, guys? Where do you think the name? Now, once I open the page 500, I see the details of all Jacks. All Jacks are showing over here on page 500. So where is Smith? Towards the left or towards the right? The telephone directory is sorted alphabetically, right? Anyone? Towards the right, correct? So now I know that my search is not there in these 500 pages. So I will tear those pages and throw off. And now my new search area will be between J and Z. Between J and Z. So now again I open the midpoint now. Page number 750 I open. Okay. And here I see the name someone with V is there, okay? Someone with V, okay? Let's say Venkatesh. So when I open the page 750, I see Venkatesh. Now, where is Smith now? Between page 500 to 750 or from 750 to 1000? Who can tell me? Who can tell me? When I open page 750, I see Venkatesh over there. So where is Smith? Smith. Where is Smith, guys? Smith will be less than V or greater than V. So Smith will be between J to Z or V to Z. Towards the left, right? So I tear this other half also and throw it away now. So in every search, I am filtering half of the data. So first I threw 500 pages. Now I am throwing away 200 pages. Now my name I know is between J and V. So now this was page number 750, right? So now I open page number 625, the midpoint of that. And I see the name Smith over here. So in how many comparison did I get to Smith? I got there only in 2 comparison, max to max 3 comparison, right? So this is called as binary search. So the iteration becomes faster because at each iteration you are eliminating the unwanted data. So binary search works in log of n. Okay, so I hope now you are comfortable with these complexity classes. Okay, so now if I take a programming test and I give the same question to 2 programmers and they come up with the same with a solution, the output is correct. Output of both the programmers is correct, but I have only one vacancy. So who will I hire? Output of both the programmers is correct, but I have only one vacancy. So who will I hire? So I will check the time complexity. So if I have Alice and Ben, Alice did it in O of log n and Ben did it in O of n. So who will I hire or give the offer letter? The one who has done it in O of n. Is O of n less than O of log n, Shrika? So if here in this case, Alice has done it in O of log n and Ben has done it in O of n. So who is faster? No, Gulshan, I was comparing between Alice and Ben. That program which they solved, Alice's time complexity is O of log n and Ben's time complexity is O of n. So from these two, I want to hire. So who will I hire? Alice is faster because their time complexity is O of. So even if you can reduce a small amount of time, did you all watch the Olympics this year? It was in August, right? Olympics. Did anyone follow the 100-meter finals? Did anyone follow the 100-meter finals? Noah Lyles, it was, right? Noah Lyles from the US, he won it. And by what time distance did he win? Does anyone know? Does anyone know how much time he defeated his opponent? The one who came second, what was the difference in the timing of both of them? You will be amazed to hear the difference between the time difference was 1 divided by 5,000 of a second. They both finished at the very same. They both finished at the very same time, same to same finish. But then when they went into details, they got to know that Noah Lyles was 1 divided by 5,000 of a second faster than the second person. Yeah, Shrikant. So they both finished at 9.79, right? And the one who got the gold medal was declared that he was 1 divided. So if I split 1 second into 5,000 pieces, one piece would be how much? By that much time, he won the gold medal. And winning the gold and winning the silver is very, very, very different. Gold medal and silver medal is very different. So the amount of perks and recognition you get when you win a gold is not the same when you win a silver. So even if you can improve this much of the time of the algorithm, it is a very substantial improvement, guys. So even if you can improve a millisecond, nanosecond faster, then also your algorithm is considered better than the competitor. So now going forward, whenever we are writing a code, make sure that we use lesser iterations wherever possible so that we can improve the performance of your algorithm. And whenever you're answering the question in the interview, always explain your algorithm in regards to the time complexity. So eventually the examiner will ask you, okay, I give you this question, you have solved the question, you have got the answer also. Can you calculate the time complexity of your algorithm and tell me? So you should be very comfortable and say, so if we give you a binary search problem and you wrote that binary search code, so you should, end of the day, you should say, sir, my algorithm will work in big O of log n. Okay, log n to the base 2, okay, because it is splitting into half, right? Splitting into half, so log to the base 2 times. And if you are doing a linear search, you can say, my algorithm will work in O of n times. Okay, if someone, now again, if Alice does it in O of n, and if Ben does it in O of n minus 1, who is faster now? Alice is taking O of n times. So if the array size is 10, if the array size is 10, the array size is 10, that is the value of n is 10. So how many iterations is Alice taking? Alice is taking 10 iterations. And how many iterations is Ben taking? Ben is taking 9 iterations. So who is faster? So if I need to hire, who will I hire? I will hire Ben. Absolutely correct. Because Ben has improved by one. Even if you can save one iteration, guys, is very much appreciated, very much commendable. So now going forward, just don't go and rush to get the output. Try to get the output by using better time complexity. Okay, so now just getting the output is not what is expected. Now you need to get the output at a faster rate. You need to get the output also and faster also. Okay. So now so once time complexity is explained, I wanted to discuss this now. So now let's say I have 4 candidates. Okay, Anushka, I'll explain that with the example. So when I'm explaining this example, Anushka, you should understand what is O n minus 1. Okay, good one. So now let's say I give a question. So I have 4 candidates. Okay, so I have 4 candidates. So candidate 1 is writing the answer. So if I tell accept a number and check whether it is prime or not. Okay, so I say accept a number and check whether it is prime or not. So the first candidate comes and he or she tries to solve the, what happened? I have changed the file name, right? Okay, so the same question I'll ask to all the 4 candidates. So the first candidate comes and I accepts the number comes into n. So we all know prime number is divisible how many times in its life cycle? Prime number is divisible how many times in its life cycle? So from 1 to that very number, how many times will it divide? Only 2 times, 1 by 1 and 1 by itself. So I take a for loop which starts from 1 and which ends at the number. So now what is the value of I in the first iteration? You all should be able to do your dry run, guys. In my dictionary, the person who can do the dry run of his or her program, I call him or her a programmer. I do not hold those people in high regards who write the program. Instead, I hold those people in high regards who can do the dry run of their program, because program eventually you can get on the net also. You just Google over here, just randomly go and say Gmail. Okay, just Google and say prime number in Java and you get the code. You get the code. See, you get the code. Blah blah blah. But dry run is in your mind. No one can steal dry run from you. So code can be copied and by hearted, but dry run is only done by those people who have understood the code. So if you can dry run and show it to the examiner as to what you have coded, that will influence and impress the examiner much more. So nowadays the examiner do not get impressed by just seeing the code. That doesn't give them a kick. What strikes them is how fast you have done the code. By fast, not by typing fast. By fast means by reducing the time complexity of the algorithm. So how fast in time complexity regards your algorithm is, and second, if you can dry run the code and show it to them. So I'll take a variable called integer counter and I'll initialize this counter to 0. So what is the value of counter? Counter is 0. Okay. Then what is the value of I in the first iteration? I is 1. I will check, does I go in 7th table? What will I do? If my 7, that is my n, if I mod it with 1, does it give me a 0? Does it go in that table? It does, right? So if it goes, I'll increment the count. So if it goes, I'll increment the counter. So I'll say counter plus plus. As simple as that. So now I take 2. Okay. So now this is my value of my counter. So counter was 0 and now counter becomes 1. Then I take I plus plus, I becomes 2. Is 7 mod with 2 gives me 0? No. It doesn't go into the if. Counter still remains 1. Counter still remains 1. Counter still remains 1. Then I plus I becomes 3. I becomes 3. I becomes 3. 7 mod with 3, does it give you 0? No. So counter remains unaffected. Counter still remains 1. I increments, I becomes 4. 7 mod with 4, does it give you 0? No. Counter still remains 1. I increments and I becomes 5. 7 mod with 5, does it give you 0? No. Counter still remains 1. I becomes 6. 7 mod with 6, does it give you 0? No. Counter still remains 1. And I becomes 7. And now 7 mod with 7, does it give you 0? Yes, 7 ones are 7. And you counter increments to 2. And when my I becomes 8, my loop will terminate. When my I becomes 8, is 8 less than 7? False. Loop will terminate. After the loop terminates, I will come and check the value of the counter. So if my counter is 2, then the number is prime. And if it isn't, this out number is not prime. Correct? Simple as that. So let's run and check. So if I enter 7, it says number is prime. If I enter 8, number is not prime. Why is 8 not prime? Let's check it out. So if I take n as 8, so if I take my n as 8, so 8 divided by 1, yes, 1 8s are 8. 2, yes, 2 4s are 8, counter becomes 2. 3, no, 3 doesn't go into 8's table, so counter remains 2. 4, yes, 4 2s are 8, divides, counter becomes 3. 5 does not divide, counter remains 3. 6 does not divide, counter remains 3. 7 does not divide, counter remains 3. 8 divides, yes, 8 ones are 8, counter becomes 4. And when the loop becomes, when I becomes 9, the loop will terminate because 9 is less than equal to 8, false. Now is the value of counter 2? No, it will go in else and we'll say not prime. So when I say 8, it's a not prime. So very sort of simple algorithm used by candidate 1 to find whether the number is prime or not. 91 is prime or not. Right click, run and check 91. 91 is not prime. Why is 91 not prime? Which table does 91 go into? Does it go into 17 table? 91 is not a prime number. It goes into some table. Okay. So 91 maybe goes into 3, no, 3, no, 4, no, 5, no, 6, no, 7. Yeah, 7s are, 7 13s are, right? 7 13s are, right? 7 13s are, yeah, it goes into 7 and 13, yes, so it's not a prime. Okay, so this was a solution for candidate 1. So what is the time complexity, guys? So if I am having the number 8, I am doing 8 comparisons. And if I'm having the number 7, I'm doing 7 comparison. So if this algorithm is to be expressed in time complexity, what would be the time complexity of this candidate? So when I ask them to submit, I tell them, please mention the time complexity of your algorithm in big O. So you will say the time complexity, that is, write like this, T of n. So you write T of n will be O of n. This is the time complexity. So I ask candidate 1 to submit and the output is correct. So candidate 1, time complexity of O of n. Okay. So time complexity of O of n. Perfect. Linear time complexity. So let's now open an Excel sheet and mention the time complexity of each candidate. And then we will choose the best candidate. So we will say O of n. Candidate 1 time complexity is O of n. Candidate 1. Okay. Let's take the next person now. So let's take now candidate 2 does the same question. Okay. Prime number by candidate 2. Okay, and I add main to it. Okay. Let's take the number from the user. So this much we can keep common. So what the candidate 2 does is he thinks a bit more rational. He looks at the question, okay, and he sees that 7, if I take 7, and if I take 8, so let's take on these two numbers, okay, simple numbers. So 1, 2, 3, 4, 5, 6, 7. So he says every number will go in 1 and every number will go in self. That means if a number divides by any of these numbers, means starting from where? Starting with from 2 and going till. So if a number divides by any of the numbers between 2 and n minus 1, it is not prime. So 7 divided mod by 2 is 7 mod with 2 is not 0. 7 mod with 3 is not 0. Wherever I get the answer that the number has divided on this red range, I will say the number is not prime straight away. At the very point, I will say it is not prime. So here in the red, it is not dividing at all. So if it doesn't divide at all between this range, it is prime. And if it divides, let's take for 8. Let's take for example 8. So 8, I'll start from 1 and go till we'll go till 8, right? We start with 1 and we'll go till 8. So I know every number divides by 1 by itself. So keep them aside. Don't touch them because every number will divide by them. Now my red range is starting from 2 and going till n minus 1. Now if I say 8 mod with 2 and if I get a 0, means it has divided. So straight away I will break the loop and I will say not prime. Here, if there will be any 0, I will break. So is 7 mod 2 equal to 0? No, I will continue. Mod with 3 equal to 0? No. Mod with 4 equal to 0? No. 5 equal to 0? No. 6 equal to 0? No. So did not divide at all. So if it doesn't divide by any number in this red range, that is a prime number. Now here 8 directly divides by 2. So I don't have to waste my other iterations over here. So in only one step I can tell 8 is not prime. That is faster now, right? So let's try to put this into, okay? So now my I will start from 2 and my I will go to less than n. Okay? And I will take a flag variable now, okay? I'll take a flag variable and my flag will be 0. Flag is like a Boolean variable. You can think of flag as a Boolean variable. Will have either 0 or 1. So initialize, I am initializing flag as 0. I haven't declared I, let me declare I also. So my I is going from 2 to n. So if at any point my n mod with I get the remainder as 0. Okay. So flag as 0, I am assuming it is a prime number. Okay. So I am assuming it's a prime number. So if the flag remains 0 means the number is prime. And if it divides by any of this number, I will directly set the flag to 1 and I'll break the loop. And then after breaking the loop, I will go and check my status of the flag. So if my flag is 0, because it did not divide at all, so flag remained 0 from start to end, I will sys out prime. And if it touched and it modified the flag value, I will sys out not. Okay. So here, if we would have checked the iteration count also, if I would take a variable over here, integer iteration counter, and initialize it to 0, and let's check how many times the iteration has run. So I copy this and put it at the first part of the loop, at the very first line of the loop. So we come to know how many times the iteration has occurred. So iteration plus plus. So I will say this prime, and then I can directly say here sys out what was the iteration count. How many iteration it took to display the number is prime or not. So iteration counter plus iteration. So I save this and I right click and I run. So if I enter 7, it says it is prime. It took 7 iterations, mean O of n. Right click, run a Java application. If I enter 8, it says not prime. It took 8 iterations. So time complexity was the number that many times. So O of n complexity. Let's come here now. So here also I'll take the iteration counter. Here also I'll take the integer iteration counter equals to 0. And now the number of times the loop runs, that many times I will increment the counter. And then here I will display the iteration counter also. Okay. So big O always specifies the worst complexity. Okay. Big O always specifies the worst case time complexity. So if I come here, now if I run, and if I say enter number, if I enter 7, it will tell me prime, but it has taken 2 steps less. So what is the time complexity of this now? What is the time complexity of this? To display 7. So if I will say my algorithm is performing 2 steps less than this. So I am improving on the performance, right? So those who have done their engineering and then who wants to go for MTech or ME, whatever they call them in their geographical region. So in MTech and ME, what we have to do is we have to pick up any IEEE research paper and then try to implement that and also try to improve the performance of that algorithm. So if that researcher has proved something and he is saying that my algorithm will work in time of O of n, you take that paper, you apply your own algorithms and try to improve on that algorithm. So in ME, the project dissertation stages are on this category. So you just don't have to implement any IEEE paper, but you also have to improve the performance of that paper. You have to propose that if we use this algorithm instead, so if you're using image processing, speech synthesis, whatever, any machine learning algorithm, you have to try to improve. Even one significant improvement is very much appreciated. So now this person is telling the same answer. See, this person is telling the same answer that 7 is prime, but it's taking 7 iterations. And the candidate 2 is doing the same answer, saying 7 is prime, but it is taking 5 iterations. Okay, so if only these 2 are the finalists, who would I hire then? What do you think? Who will I hire? Even 1 nanosecond of improvement is a very substantial improvement in the algorithm's performance. Here he is doing a substantial improvement. Okay, let's check the yes. Now, can you all improve it even faster? Can we improve it even further faster? Can we improve it even faster? See, now this is not the end, okay? So there is always room for improvement. So now as engineers, you all have to keep on improving the performance, okay? So now let's take prime number candidate 3 now. Okay, candidate 3 now. So I'll just copy the number. See now. So whatever is needed, I'll just copy this. See, if I take a number 100, 100 will go in max to max which table? 100 will go max to max in 50th table. 50 multiplied by 2 is 100. Will 100 go in 51 table? No. Answer will come in fraction. So number max to max goes in its half. So what this person does now, third candidate, to improve the performance, see what he does. He takes the same algorithm, okay? So you have to take the same research paper. Just if you can do a small fine tuning also is more than 9 o'clock. हाँ sir. 2 minutes नीचे. जी sir. Yes. So even if a small improvement, what is this? Okay, we did not add main. We did not add main. That's why it was telling. Now this person takes the same research paper of candidate 2 and says instead of going till the less than n, even if you go till the half of n is more than sufficient. You don't have to go till the n. So if I take 100, 100's max to max, if it will search till 50, it will not go till 99. What was this person checking? To check 100 is starting from 2 and going till 99, wherein 51 till 99 were all unwanted. So if I right click over here, run, okay. So he is just wasting the iterations from 51 till 99, okay. So if I say 93 is not prime, And if I say 90, okay, which is the okay, give me a prime number from in the range of 70 to 80, or in the 90s, which is the prime number in the 90s? Prime number between 1 to 100. Yes, okay, so 97 is a prime number. So see, to check whether number is prime or not, this candidate 2 is going how many iterations? So total 97 is taking 95 iterations. It's taking 95 iterations to take, because it is using n minus 2, right? So what this candidate 3 took is, he says, if you are checking 97, it will go in his half, max to max, it will not go more than half. So he just says n by 2. So start from 2 and go till n by 2 is more than sufficient. No need to go to 99. So run. So let's check 97. So it's telling prime, and in how many iterations? So now this all more further improve the performance. So what is the time complexity of this now? Time complexity of this would be that whatever value of n is there, I am going till the half of that n, and I'm starting from 2, not with 1. So half also, and reducing 1 over here also. So half minus 1. So what is the value of the n? Half that n, and from that subtract 1 also, because I am running from 2, not from 1. Are you getting, guys, how we are trying to mention the time complexity? Yes. Sandhya, O of n by 2 minus 1, not O of n minus 1 by 2. Got it? I hope you all are able to relate with these terms, guys. These are very important for your interview preparation. You all should be comfortable in answering time complexity related questions. So O of n by 2, and in that I can also say minus 1 also. So this would be better. So whatever is the n, half it, and from that also minus 1. Now, there is one more solution to this, which is the fastest. Can anyone think of that? That is candidate 4's answer. So now the output is not what is important. What is important is the iteration which you take to come to that output. Yeah, Gulshan, you think of that. It's complex, so it is called complexity. But you have to, as engineers, always prove your point with some complexity. You just cannot say that. See, because if I say time as a factor, so if someone has a i7 CPU, naturally his code will execute faster and get the output. And if someone has a i3 CPU, his code will be slower than i7. So this is not the factor that, it's the CPU time. That's why we check for iterations as engineers, whose iteration is lower. So the person whose iteration is lower, yeah, if you add that, then one iteration will increase unnecessarily. First check for the number is odd, and then yes, you can Try and check what are the total. Then you have to you have to count the iteration for first, checking for the odd number and then checking for the prime number. Okay, now I'll go to the fastest one. Now see, this is the fastest. This is the fastest. So if you are told to write prime number, use this one. I know that a number will divide by 2. Okay, so I'll just take this entire stuff. Okay, so I'm just improving on that research paper only. See, I'm not reinventing the wheel. Whatever previous scholars have researched and presented, I take that thesis and then I add on that same thing. So if even one small change you can make, you can be awarded a master's degree. Even a PhD can be awarded, because I have the same concept of PhD also. So I say what? See, if I take a number 100, if it goes into 2 and less than the square root of that number, then also, so if I say 100, so if I say the number is 100, so what is 100 square root? The number is 100, so square root of 100 is 10, square root is 10. So if that number divides from 2 to 10 by any number, it is not a prime. So if I divide by the square root of that number, is not a prime number. So let's save this and let's check. Run Java application. Let's take 7. So it's saying, see, in one iteration it told me number is prime. Only in one iteration it took. Just in one single iteration it told me. Let's check 97. It's prime. It took only 8 iterations. How many iterations it took? So now let's start comparing. So let's take 97 as a benchmark. Let's take 97 as a benchmark. So 97, how many iterations? O of n, right? O of n. So if I say enter number 96, it took 97 comparisons. Okay, this should be a good learning curve for you. Let's come 10-second algorithm. Another Java application. I enter 97. It took 95. So 2 better than that. Some improvement was there. Okay, should be acceptable. Some improvement is a very big improvement. Let's take the third person, what he did. The third person, 97. He did a substantial improvement. Okay, perfect. So now uses the formula. Okay, this is the generic formula. So this is it. 97 is of n minus 2 minus 1. So took 47 iterations. And now come to the best over here. The best of the lot. So if I enter 97, it will take only 8 iterations. Isn't this faster? Isn't this faster, guys? So O of square root of n. So square root time complexity. And minus 1 also. So if square root of 100 is 10, square root of 97 might be 9. 9 minus 1, 8. So it took 8 steps. Guys, do you understand the question? What we tried to achieve over here. So all are getting the same output, prime, not prime, prime, not prime, but the iteration count, all are improving it. So as the loop starts, I'm writing the iteration counter. Does this make sense to you all? I'll copy, paste this code into our repository and push the code. Those who are practicing will be a good help for them. I hope you are practicing on a daily basis, guys. For the interview time complexity, you should bring it up and try to channelize the interview in the direction which you want it to go. Okay, I'll push this code on GitHub. So you are watching the GitHub tutorials, watching the code on GitHub. Who is checking the code on GitHub daily basis? So let me push the code for today and I'll be back. So guys, I hope these sessions are a bit helpful for you all in preparing for your forthcoming interviews and your campus drives or wherever you all are appearing for an interview. I hope you guys are benefiting from this. Yes, guys. Yes, Anushka, as the sessions progress, we will try to include the Spring framework also in the curriculum. As we're in the initial stages, we are just doing the programming fundamentals. As we progress the session, I'll include collections also and Spring MVC, Spring Boot, little bit of front end also I'll include. But I hope you all are comfortable and getting the concept clear, guys. Very good. Yeah, so just push the code on the GitHub repo. Okay. And you all have the link, right? I'll just refresh the link also once again. I'll refresh the link once again, so you all can just take the code from here. Okay. Yeah. You understood this code, right? You all got the use of the flag, right? What the flag is doing. So the flag is just like a Boolean variable. I initialize it to 0, and on any condition I'm setting the flag. So if that n goes into any of the table between 2 to the square root, I will set the flag to 1 and I'll break the loop. There's no need to go further because if the number is 8 and 8 divides by 2, then no need to check with 3, 4, 5. So I break the loop in that case. Does anyone have any queries, questions to ask from today's session or any of the sessions? Or you faced an interview and you asked a particular question. So I gave an interview and the interviewer asked me this question. So can you help us with the right answer? Yeah, I'll squeeze in some SQL also. Maybe in this end of the week, Gulshan, I'll squeeze in some SQL also, Shreyash. Yeah, we'll try to study some SQL and some use cases of SQL also. Yeah, I have that in mind. SQL is there, Spring Boot is there. I have that in mind to cover these courses. Yes, anyone else has any queries, questions to ask? Sushmita, you need to ask anything?
No, sir, you can wind up the session.
Okay then. Okay, guys, then I'll see you all tomorrow at sharp 7. We'll progress from this topic onwards, okay? Okay, guys, take care. Bye.
Yeah, thank you, sir. So, students, I have shared the attendance link again. Kindly mark your attendance. If you are done with the attendance, you can drop the session. We'll wait for 2 minutes, then we'll wind up. Before that, kindly mark your attendance.